By definition, the absolute value of a real number a is equal to its distance to 0 on the real number line. So what that means is that the absolute value of a then will be equal to a if a is greater than or equal to 0 and minus a if a is less than 0. Keeping this in mind, let's complete the following problems. Let's rewrite the absolute value of 3 minus x without the absolute value symbol. To do that, we want to use the definition of absolute value. Now, according to what we just discussed, the absolute value of a is equal to a if a is greater than or equal to 0 and minus a if a is less than 0. So, the absolute value of 3 minus x will be equal to 3 minus x if 3 minus x is greater than or equal to 0 and minus 3 minus x if 3 minus x is less than 0. And let's rewrite that by solving just for this inequality over here on the right-hand side. So then the absolute value of 3 minus x is equal to 3 minus x if, solving for this, we get 3 greater than or equal to x, or we would rewrite it as x less than or equal to 3. And it's minus 3 minus x if, solving for the other side, for the other piece, we get 3 less than x or x greater than 3. Now let's look at the following. Let's rewrite the absolute value of 2x plus 3 without the absolute value symbol. So by definition of absolute value, the absolute value of 2x plus 3 is equal to, it's 2x plus 3 if 2x plus 3 is greater than or equal to 0, and it's minus 2x plus 3 if 2x plus 3 is less than 0. Now let's rewrite that nicely just by solving for these inequalities on the right-hand side. So that's equal to 2x plus 3, and if we solve that, we get 2x is greater than or equal to minus 3, or x is greater than or equal to minus 3 halves. And if we solve the second one, we get minus 2x plus 3 if 2x is less than minus 3 or x is less than minus 3 halves.